all right, let me send a link so I remember when I did it. Cool. 866 prime palindrome. Find the smallest prime palindrome greater than or equal to n. We call that a number is prime if it's wrong. It's only divisors are 1 and itself and it is greater than 1. For example, some numbers are prime. We call that a number is a palindrome. It reads from left to right as it does from right to left. Okay. The smallest number palindrome. Okay. Thanks. Yeah, I mean it's fun. I mean, though, a lot of people hate it though, so I hope I'm not one of those people later. But okay. So is the smallest bigger? Okay. Mm, well, uh, so I think one key thing is kind of figure out how to, which is maybe more interesting. It's kind of so I mean the naive way is just like while n is not prime palindrome n plus plus or something like that, right? But it'll probably want that in time, especially to 10 today. But hmm, so the other thing is. Hmm, so I mean, so the thing you would do is basically, ideally, is to generate half the palindrome and then mirror it and then check to see if it's a prime. I'm trying to think about how, like, what's the clean way to do it? Uh, and it doesn't seem like there are many of them though. So maybe we could even, can we do something clever? So also that would be a hard edge case to generate the mirroring thing for, but that's okay. We have to use long. Oh, 10 to the 8. No, that's okay. Uh, wow. So the one after 11 is 101. I actually wonder how many there are. I think you could probably just generate a table of them even. But what's 10 to the 8 again? 10 to the 8 is 100 million. Okay. I always confuse 10 to the 8 to the 10 to the 9. So I'm just really bad at it for whatever reason. I cannot do scientific notation clearly. Uh, but okay. Yeah, I mean, I think so. Okay, so we know that it's less than 10 to the eighth, so I think we could actually just generate all of them. I think that's how I would look at it, and then take the min that's bigger than n, if that makes sense. Uh, I think we don't even have to. I mean, maybe you could play around. Oh, yeah, and then you could binary search after that, actually. Yeah, yeah. Oh, sorry, I misread that a little bit. But yeah, um, we just generate all of them because there are only 10 to the fourth possible ones, or maybe 10 to the fifth, depending on how you do off by one. And then once you generate all possible set, then yeah, then we just kind of like binary search to get the smallest one that is bigger than that number, and then that's it. Yeah, I think that's what I'm gonna do. Hopefully that makes sense. Yeah, you just generate the like I said, you just take half of it and then you generate and then you check to see if you know. Okay. Yeah. Okay. Uh, let me just double check in my head that I'm counting correctly because counting is hard. It's 1,000, so we probably need up to, I guess technically 2,000, depending on how I want to do it. But I'm just going to do it up to 10,000 because why not? Put it in a way, I guess so. A pen is not that expensive, is it? I actually should have a better idea in my head. Maybe I should use another data structure, but it's fine. Okay. Now, if So we want 2 of them. What is it? Is there a clean way to do it? Sorry, I'm just trying to think if there's a clean way to do it in Python. Like you could reverse the string maybe, I guess, but maybe that's what I'll do. Is that slow? I guess you only do it 10,000 times. Well, we'll see. You can optimize this if we need to, but I'm like this. Is that good Python? I always forget whether this string is iterable. Oh, well, yeah, okay, fine. You're right. Yeah, you could definitely make optimizations. I think I don't think I could. I was thinking about that one, but I don't know if I could prove it. Like, because just because the suffix is a prime, then doesn't mean that the I don't know. I couldn't prove it in my head, but maybe there's some truth to that for sure. Um, okay, I mean that looks like it's good. So if that is prime. I think also randomly speaking, in theory, we could create some kind of prime sif, uh, but I'm lazy, so maybe. I had to think about it actually. Hmm. Yeah, well, let's play around this. Maybe this is not that as fast as I thought it would be actually, but this actually has potential to be very slow. But, okay, fine. Oh, I might have to do some cleaning up and optimizing a little bit afterwards. So we want all except the last character. So okay. Maybe I'll do this without. Yeah. Okay. And then sort. Bisect, bisect. Something like that, I think, right? And now there is a lot of places to make improvements. So we'll see. So this is a string. Execute this. And then we have fx2 0 0. Maybe I should have done this in C++ because now I'm worrying a little bit about performance, but maybe it's fine. For yeah, I don't know how to do a normal for loop in Python either. No, you could actually be slicker on this for the CIF reason, but I think that's where I would begin. Oops. No, is that not? Oops. That's what I get. Copy myself. Actually, someone taught me this trick before. I forget what it is. Like something like this. I was not thinking about it, but now maybe it's helpful. Also, did I do it the right way? Yeah, okay. No, I think so. Because I just worry about where the 0 is. Okay. I don't know what the output. What's the output? Where did I put? Let's print out the first 20 characters. Oh, it's sorting the string. That makes sense. But this also, the running time wise, I should do every possible ones all the time. So that's good. Oh, this returns the index. So that's right. That's why we test stuff. But let's just do a couple. Let's say, okay, that's good enough. I don't know. It could be 1. Did I check for 1? Yeah, I might have screwed up 1 actually. Why do I start? Oh, so that when I do double. Oh yeah, I also probably missed 2. You are right. But yeah, that's what I'm checking. That's my excuse. I'm sticking to it. Also, I mean, I would have tested it. So, though of course on the contest they would not given you the answer. So I might have had to make sure that I keep in track. Yeah. Let me point the first few characters again. Just I forget if 10 with 1 is in it. Hey, Brainer Society. Nice to see you. Okay, yeah. Let's say 2. Okay. And we're going to remove 1, because 1 is an input. Well, maybe I'm just lazy. Return 2. Right? Because I don't have to. No, I didn't. I already removed the point. Huh. With 2, I output 3. And for 3, I'll put 5. Okay. I have to do bisect left or something? Oh, I always confuse bisects. I'm just going to look it up for a second. But I mean, I could just do -1. I think that's fine. There are no adjacent prime numbers. Okay. Well, there are no adjacent prime numbers except for 2 and 3. I feel like someone's going to catch me. I have a wrong number though. 8, I return 9. Why is 11 expected then? Well, 9 is not a prime number, so of course it's. But why am I? Okay, 1 second. What is that? There must be a typo somewhere, but I think time-wise, I think we're doing okay in terms of running time. Oh man, it took a second, but maybe we could cache it somewhere. I don't know if there's a, but 1, 2, 3, 4, 5, 7, 9. Why does this code think it's because this is Leetcode 2? Okay, fine. Yeah, okay. Oh man, you are right. Why do I? Oh yeah, I mean, so basically, yeah, it's the same reason, which is that for perfect squares, I didn't check it. I meant to, but I'm just bad. But now I'm getting why does this change that? Oh, and let's just change it a little bit to the wrong answer first. Oh yeah, good luck, Mate Sewell. Hope I'm saying that right. It's always hard to parse these things. yeah, definitely a lot of wrong things here. Even 131 as well. Maybe. But wait, is 131 prime? I don't know anymore. I'm kind of losing my mind. Okay, I don't know why I did it that way. There you go. But why does it? Oh, I always forget that I have a diff button. Okay. Huh, that's what I had to do. What was I? Oh, because the current. Okay. Oh, I'm glad I fixed that. Yeah, we'll see if it runs fast enough, actually. I mean, it runs fast enough here, which is okay. Maybe we needed a prime sieve, but maybe not. Hopefully not. Yeah. Oh, man. I mean, it's just because of the summation of all the timings. Uh, huh. Is there a way to clean that up? Uh, Also, maybe it's just too many. 10,000, because I think it only goes up to 2,000 something. Uh, yeah. Okay, fine. Let's see if that one's faster. I was kind of just being lazy on this one, but oh, maybe a little bit bigger then. Let's say, let's do 3,000 then. No, the answer is guaranteed to be less than it. What input is? Huh. So I might as well put this in here. 8, kind of freebie. Might as well use it, right? Um, the fifth one. 2, 3, 4, 5. That's women. Kind of confused, but I didn't really change anything that would have. It was time to exceed it, but it wasn't wrong. What did I? Huh. So maybe I don't have a big number or bigger than 2 million. Now I want to. Let me look at the size of this thing. Maybe I could just hard code the big case. Maybe that's what they kind of want you to do. It's 782, so that's okay. Hmm. The last 10. Oh, what am I doing? I usually just take requests. Though the next one should be a hard one. So you want to ask me a hard one, I will take a look at it. Though I'm not going to get ahead of myself because I'm having some issues here. I do it. Am I even using mine? Okay. So there are actually a lot of them. And this is only, oh, because this is only 10 million. 1, 2, 3, 4. Maybe I need a smarter way. Let me think about this for a second. I thought I could brute force it, but the problem is you can't reuse some of the answers between problems unless I'm wrong. I don't know if there's a thing, so that makes it a little trickier. We could definitely be smarter about some stuff, but uh, like I'm also just thinking of like optimizing clear stuff. Is that good enough? Or I definitely need this to be bigger. maybe I just do need 10 to the 8 again. Is that big enough? Okay. Yeah, that's what I guess so. I feel like that kills the spirit of these things, but yeah. Is it against the spirit of these things? I don't know. But and also I need to like run this locally, I guess, and generate a list and then paste it. Is that is that the preferred way to? Ooh, I almost clicked on submit by accident. That's why I don't play Counter Strike. I am terrible at clicking. Oh man, so do that. What am I doing this one? Should be right. Am I missing numbers? That should be enough zeros, right? Yeah, way more than enough. Something's wrong with my code, I think, too. Maybe. Because well, I feel like this should have enough digits, right? No, that's short by 1 digit. Okay. I need this, but okay. I need some version of this, but even shorter. That's annoying. Then if we need to just do a lookup table, I mean, if we do, we do. Maybe that's why everyone hates this farm. That's my okay, fine. I'm just gonna do this a little, not offline. I'm just gonna use this code and then create a file. Give me a second. I don't have this thing set up because my computer is a mess. But what the answer is? Oh, that's true. But I think because like I worry a little bit about like having to print a lot of stuff and stuff. I don't know. I don't know if that's a thing. Oh man, what am I doing? Oh. Okay, so that kind of worked. Is that enough digits? Now I have to make this slightly bigger. That actually went pretty quickly on my local computer. Yeah, took 1.5 seconds, which is not quite good enough for not quite good enough for each prompt to be that much. But okay, fine. Okay, might as well remove one while I'm at it. Is that even the right indent? Yeah, the coloring stops afterwards. Okay, so I have to be here. I think, okay, let's just try it. Okay, well, that's unfortunate. Where's the line 18? Oh, that's because I didn't. Okay, fine. I could just remove this now. I could play around with it later. Okay. Am I happy about it? No. Where's my? I did I type it in? Oh, usually I paste the test cases somewhere, but I guess this time I actually forgot. I mean, it doesn't really matter, I think. That may be I have to test the 1, 2, and 3, actually, just in case. Yeah, so fast. But, no, think about the diff ones. I don't have to keep looking. Okay. Yeah, I added 1, 2, and 3, but, um, and it seems like it's getting the right answer, so I'm just gonna submit. Eh, well, I mean, I really don't know if it's in the spirit of things. I really, I'll have to kind of see if that. I would say, to be fair, that is something that is more practical in the real world than a lot of things you do. To be fair, like in the sense that sometimes you just put stuff in the lookup table. I know, right? But it's not like it's not like I look up the answer and then cheated. We wrote the code together. It's just that and I think in general, what you would do, even in real life, is you would cache it, right? Like I have a generator. I just don't want every problem. So I think that seems fair to some degree. Um, and as I mentioned, I think in real life you would most certainly do something like this if you know that. And this is like very small, relatively file size wise. So, so at least that's actually more relevant than a lot of other things people do for algorithm things. And it would make for interesting interview conversation. But is there a hint on this one now? I don't know if this is. But okay. I mean, I think I don't think I've seen this particular problem, but for whatever reason, interviewers do like to ask about prime questions, and I definitely have done something like this. I think it. I think the other thing that you could have thought about is what I was talking about earlier, where you have the prime of Severus. Actually, Sif of what did I say? Sif, not prime of Sif of I forgot the person's name. Sif of Aristodenes. I don't know. Here, if you want to Google it, this is it. But so definitely look that up if you have to. Um, and these are things that I would talk about in an interview about what I know about primes in general. So maybe I should remember the name. It's been a while. But the problem with this, and I don't know if this is specific to maybe like I don't know how Leetcode we use caches or whatever. Because in theory, because I know that some other type of online judges or whatever, some of them do allow for kind of like like saving states in a weird way between problems, and this is usually more relevant to primes or some kind of like caching some f of x is equal to some whatever, where f of x doesn't change in depends on parameter, which obviously for prime it generally doesn't. Like a prime's always going to be prime if it is or it's not. Um, so those are things that are important. But uh, but yeah, so people do ask about prime, so these are things that I would bring up. But beyond that, I think I mean even the SIF may not be super necessary because like at some point you're talking about number theory with people and number theory is interesting and people do it as a hobby and maybe if you're doing crypto stuff, not the coins, cryptography. Well, maybe the coins too. I actually don't know that much about crypto coins or cryptocurrency and how they do stuff. Though I know that there's some prime somewhere for factoring purposes. But so like maybe that's a thing that you need to know if you're into cryptography or something like that. But I think in general, like prime number problems are a little weird. I think this one, the key takeaway is that if you write your generator such that you could you don't check every number, I think that should be good enough. I think some cool guy point out that maybe you could have constructed from primes first. I'm not sure I'm convinced about this, to be honest. I feel like you could have like some weird like, for example, like this number, it's definitely not a prime, and I know that is so I don't know. Excuse me. Um, but and maybe there's some smarter optimization. Maybe I'll play around with the discussions later. But yeah, overall, I think it's not. I mean, I think also in an interview on a problem like this, time constraints are not as tight as they are on an online judge. You have more than 10 seconds for it to run. If it's way more than that, that's where you talk about like reusing. In this case, it's not really cache, but like reusing some kind of pre-generated, um, pre-calculated thing. It's a thing that comes up. Um, but yeah, no, that's what I mean. Like in the real world, you would definitely pre-calculate everything. So I think in terms of what I'm talking about, like in terms of interviews, that's what I would talk about. So like the running time doesn't matter that much. Like and like in it, and maybe this is just my unfamiliarity with Leetcode, but in the real world, I would I would like we wrote the generator for this, so it's not like we didn't write the code. We would generate it once, and then uh, for future queries, you just keep on query against that lookup table, right? So that would actually be, what I would have hoped for. And for an interview, that probably should be good enough as long as you make sure that you don't recalculate every time. Um, and I think in that sense, it's something that I would expect on an interview level, kind of a little bit, or I would expect a lot of the philosophies that are in this problem to be used in an interview. Maybe not necessarily the prime part, but some like function that takes a little bit of time, especially yeah, and that's the stuff that actually has like the most real world application, right? I think like cool guy mentioned as well, because like you have this operation that's costly. What do you do? Well, the answer is just cache it up and then put in a lookup table and or something like that. So, but yeah, so definitely recommend digging into a little bit. I guess I could have also, let me try to find my code. I have it somewhere because I had to run it, but because I want to talk about the complexity a little bit. But I mean, complexity for this is always a little tricky because the input in terms of bits is a little tricky. Um, but in this case, we will have two parts. One is the pre-calculation, or yeah, pre-calculation, which just what I end up changing it to. Let me double check a little bit. Uh, yeah, so I did 20 iterations, 20,000 iterations, which is a constant number, and then you just look up primes up to that. Um, so it's not, so yeah, so that's kind of how I think about it. And the space is just, well, the number of primes up to that number or whatever it is. And actually, I probably put way too many on here, but it's fine. As long as it's correct. Because it's not that big of a deal, maybe. Yeah. But yeah, that's what I think I have to say about this one. Did any? But overall, I mean, I, eh, I have to see what the intended solution is before I hate on it. But I thought it's okay. Like I said, it's a lot of things that you know components that you would actually use for real life. Yeah. That, yeah, and yeah, I think creating a prime number iterator would be a decent problem, and that's where you need to sift, I think, for the first n prime or something. That's